Hello and welcome back to your channel Physics Safari. My name is Abhishek and today we are going to discuss the fifth video lesson on the work energy power. I believe you guys have understood whatever we have discussed so far. एक फटाफट बता दो what is work. So let me tell you, work is all about transfer of energy to a system or from a system by a force is called the work. If I giving the energy, if the work done is positive, it means we are giving the energy to the system, and if the work done is negative, it means we are taking the energy away from the system. ये basic बातें हमने discuss कर लिया था. We have also done certain amount of energy, certain amount of numericals. My bad. Today we're gonna do some more numericals on the work kinetic energy theorem. तो work kinetic energy theorem क्या बोलता है? That net work done by the forces is equals to change in the kinetic energy of the particle. ये सिर्फ पार्टिकल सिस्टम के लिए डिफाइंड है क्योंकि सिर्फ एक पार्टिकल सिस्टम के पास जो एनर्जी होता है वो किनेटिक एनर्जी ही हो सकता है. फॉर द सिस्टम ऑफ पार्टिकल हम आगे देखेंगे, वहां पे नॉट जस्ट किनेटिक एनर्जी बट वी कैन आल्सो हैव द चेंज इन द पोटेंशियल एनर्जी एज वेल. उसके साथ हम लोग और भी देखेंगे नॉन कंजर्वेटिव फोर्सेस के द्वारा भी किया गया काम्स को वी गोना सी. But for now, let us confine ourselves towards this concept, जहाँ पे the net work done is equals to change in the kinetic energy of the particle. इसको हम लोग work energy theory बोलते हैं for the particle system. हम लोग इसी को आगे और भी इसके expanded forms में पढ़ेंगे when we deal with the system of particle. ठीक है ना जी? All good then. Let's quickly start. Okay, let's quickly start with one simple question, and it says that let us say I have an object being kept over here. एक object हमने रखा and at time t is equals to 0, its velocity is 0. All good. Now let us say that the mass of the object is m and it is under a force, it is acted upon by a force, let us say F. और यहाँ पे we have a friction, the surface is rough. So let's suppose the coefficient of friction between the surface and the block is mu. Now we can ask you multiple questions on this particular frame. इसमें बहुत सारे क्वेश्चंस हम आपको पूछ सकते हैं. ठीक है जी, तो चलो क्वेश्चंस का एक लिस्ट बना लेते हैं दैट वी आर गोइंग टू आंसर. नाउ द फर्स्ट क्वेश्चन टू यू शुड बी फाइंड द वर्क डन बाय दिस फोर्स. सो वर्क डन बाय दिस फोर्स कब तक? फॉर अ सर्टेन टाइम टी, फॉर सर्टेन टाइम टी. हम लोग सारे क्वेश्चंस को for certain time t के लेकर ही करेंगे. We're gonna find the work done by the force in time t. So it's gonna be very much generalized. हम लोग expressions को derive करेंगे. Second thing that we have to find is the work done by the friction. Since we have the coefficient of friction when the surface is rough, we're gonna have some friction and we have to find work done by the friction. Now, third thing which I want you guys to find is work done by the gravity. Fourth thing which I want you guys to find is the work done by the normal force. Now I also want you to find the total work done and the velocity. Last question should be velocity of block at time t. अपने को इस टाइम t पे इस ब्लॉक के वेलोसिटी को निकालना है. तो एक चीज तो बहुत सिंपली हम लोग को समझ में आ रखा है कि since some work is getting done, तो that energy will be converted to the kinetic energy. अपने को उसमें कुछ kinetic energy तो आएगा ही आएगा, है ना जी? बढ़िया. तो पहला क्वेश्चन स्टार्ट करते हैं. टू सॉल्व इट हम लोग स्टार्ट करते हैं वर्क डन बाय द फोर्स. अपने को निकालना है वर्क डन बाय द फोर्स. तो लेट अस से दैट व्हेन वी अप्लाई द फोर्स ऑन दिस, the body will have a tendency to move towards right. तो एक फ्रिक्शन फोर्स जो लगेगा वो इसके इस तरफ लगेगा in the opposite direction, so that will try to stop this relative motion which is trying to take place. ये relative motion जो यहाँ पे होने का कोशिश कर रहा है वो निकालने का वो that will develop. Okay, because of this force, if this force is more than the maximum static friction, the body will start moving. Simple सी बात है, इस बात को दिमाग में रखना. अगर maximum static friction से force ज्यादा हो गया तो body move करना चालू हो जाएगा. And then the kinetic friction is going to act. So the net force acting on the body is going to be constant. Net force acting on the object should be how much? Force in the forward direction and the friction force in the backward direction. So that is going to be the net force that should act on this block. नाउ टू फाइंड द फ्रिक्शन फोर्स व्हाट डू वी नीड द नॉर्मल रिएक्शन। तो इस बॉडी का जो एफबीडी होगा, इस बॉडी का जो एफबीडी होगा, लेट अस से हियर वी हैव द ब्लॉक और इसका मास डाउनवर्ड, नॉर्मल रिएक्शन इज गोइंग टू एक्ट अपवर्ड। इस पे एक फोर्स लग रहा है इन द फॉरवर्ड डायरेक्शन एंड द फ्रिक्शन फोर्स इज एक्टिंग इन द बैकवर्ड डायरेक्शन एंड वी डू नॉट हैव एनी अदर फोर्स अपार्ट फ्रॉम दिस। Now, since there is no vertical motion taking place, that means the normal reaction should be equals to mg. Normal reaction is going to be mg in this case. कोई मुश्किल नहीं है, मैं थोड़ा फटाफट इसको खत्म करता हूँ क्योंकि ज्यादा इसमें कुछ है ही नहीं, है ना। Normal reaction is going to be mg. It means the friction force is going to be mu times of mg. Assuming that ये जो force है static friction से ज्यादा है तभी body move करना start करेगा, or is the body is not going to move, that's for sure. Now, since we have friction force हमने निकाल दिया है, so the net force acting should be how much? You know, F minus mu times of mg. Now we're gonna find the acceleration of the object. Body में कितना acceleration हो रखा है that we can easily find now. So acceleration of the block should be equals to this F minus mu times of mg upon m is going to be the acceleration in the block. That is going to be the acceleration in the block. If I know the acceleration, I can actually find the displacement of the object in any time t, and if I can do that, I can easily find the work done by the force, because work done is all about force into displacement. ये अपने को already पता है, ठीक है। तो डिस्प्लेसमेंट निकालने में कोई मुश्किल नहीं है। At time t is equals to 0, its velocity is 0 and the body is undergoing a constant acceleration. ये अपना एक कांस्टेंट एक्सेलरेशन है, तो s शुड बी हाउ मच? s शुड बी ut प्लस हाफ t स्क्वायर। u 0 है तो फटाफट कर दो, हाफ a इज हाउ मच? f माइनस म्यू टाइम्स ऑफ mg अपॉन m हो गया बच्चों, दिस इज योर a एंड t स्क्वायर। Since I got to know the displacement, I can easily find the work done by this force. The work done by the force should be how much? Force into the displacement. And the angle between the force and the displacement is 0 degree. तो हम सिंपल Fs लिख सकते हैं, इस पे हमने ऑलरेडी बहुत चर्चा कर लिया है। तो your work done should be how much? This into the force. तो आप ऐसे लिख दो F t square upon 2 नीचे हो गया बच्चों, and this is going to be F minus mu mg upon your m. So this is the net work, this is the work done by the force F as shown in the figure. F is acting towards right. इसमें किसी को कोई दिक्कत होना आई बिलीव कि नहीं चाहिए, है ना जी। चलो हम लोग थोड़ा आगे बढ़ते हैं। लेट अस गो अहेड एंड ट्राई एंड सॉल्व द नेक्स्ट प्रॉब्लम। हम लोग अब सेकंड को सॉल्व करते हैं। सेकंड क्या बोलता है? वर्क डन बाय द फ्रिक्शन। ये तो हो गया। नाउ वी हैव टू फाइंड वर्क डन बाय द फ्रिक्शन। देखो डिस्प्लेसमेंट विल बी सेम बट द फ्रिक्शन इज एक्टिंग इन द ऑपोजिट डायरेक्शन, सो द सेकंड पॉइंट दैट वर्क डन बाय द फ्रिक्शन शुड बी हाउ मच? फ्रिक्शनल फोर्स इनटू द डिस्प्लेसमेंट, और एक माइनस साइन हो जाएगा क्योंकि फ्रिक्शन इज ऑपोजिट टू द डिस्प्लेसमेंट। अपने को डिस्प्लेसमेंट भैया पता है, डिस्प्लेसमेंट इज नोन टू यू, फ्रिक्शन फोर्स इज आल्सो नोन टू यू। अपने पास कुछ और मुश्किल तो होने वाला है नहीं। दैट शुड बी हाउ मच? म्यू टाइम्स ऑफ mg, और डिस्प्लेसमेंट वी कैन इजीली पुट t स्क्वायर अपॉन 2 ब्रैकेट f माइनस म्यू mg अपॉन m, है ना। ये हो गया वर्क डन बाय द फ्रिक्शन, दैट इज द वर्क डन बाय द फ्रिक्शन। ऑल गुड। Now the third point says work done by the gravity. Since there is no vertical motion, there is no motion in towards the gravitational pull or away from the gravitational pull, it means the work done by the gravity should be straightforward 0. So the work done by the gravity is going to be 0. Likewise, also for the normal, there is no vertical motion, so work done by the normal force, work done by the normal should also be 0. कोई दिक्कत वाली बात नहीं है, ये दोनों हमने निकाल दिया। Now the total work done, if I look at the entire thing, the total work done should be what? The work done by the force and the work done by the friction. दोनों को प्लस कर देंगे तो total work done could be given as total work done total should be equals to work done by the force F plus work done by the friction. इसको तो ऐसे हम लोग मैन्युअली सॉल्व कर सकते हैं, इसको प्लस इसको कर देंगे, then that is going to give you the work done by the total forces, you know, net work done should be given by that. But हम लोग ऐसा क्यों करें? Why should we do that? Can we just find the net force? Net force निकाल लेंगे। Net force is how much? F minus mu mg, and the displacement is how much? This much. So the net work done is going to be, net work done could also be found out as, net work done could also be found out as F net into the displacement. अपने पास F net कितना है बच्चों? F minus mu mg, तो निकल जाएगा F minus mu mg and the displacement is how much? यहाँ से पुट कर देते हैं ना, तो if I use that I should be having 1 upon 2 F minus mu mg upon A and times of t square. If you do simplify a little bit, this part becomes square. तो अपने को क्या मिल जाएगा? देखो बड़ा आसान है, मुश्किल तो है नहीं. So the net work done should be how much? F minus mu mg times t का whole square और times whole square upon 2a. 2a कोई मुश्किल नहीं है ना. So that is the work, total work done. That should be the sum of the work done by the force and the friction. Also we could have found, as we have done, net work force निकाल लो और distance से multiply कर दो, तो अपना a भी हो गया. Now the next part is velocity of the block at any time t. The velocity of the block at any time t. तो हमने क्या पढ़ा है कि net work done by on a particle system should be equals to change in the kinetic energy. I should rather apply that. हम लोग उसको अप्लाई करके फटाफट सॉल्व कर सकते हैं, या फिर आप काइनेमेटिक्स भी इसमें लगा सकते हो. velocity could be given as v is equals to u plus at. अपने को पता है और उससे भी हम कर सकते हैं, उससे भी हम कर सकते हैं जी, है ना. या फिर फटाफट हम लोगों ने यूज दिस. तो काइनेमेटिक्स तो ऑलरेडी आपने को पता है, तो क्यों ना हम लोग वर्क एनर्जी थ्योरम का यूज कर लें. नाउ द सिक्स्थ वन सेज you have to find the velocity. We know that net work done is equals to change in the kinetic energy. अपने को ये बात पता है ना, नेट वर्क डन इज चेंज इन द काइनेटिक एनर्जी. तो भैया नेट वर्क डन कितना है ऑलरेडी हमने निकाल रखा है, तो इसको बोल सकते हैं क्या? F minus mu times of mg whole square t square upon 2 times of a is the net work done. That should be final kinetic energy minus initial kinetic energy. और initially कितना है? 0, because initial velocity is 0. तो final velocity मान लो v है, तो half mv square. So yes, we can use it. कुछ कैंसिल हो रहा है क्या? चलो भाई तुम तो जाओ. ये कहाँ से आ गया? ये कैसे आ गया? या ये मास है, दिस इज मास. ये मास था, यहाँ पे ए कैसे आ गया? ये तो गड़बड़ हो जाएगा ना, बिकॉज भैया हमको तो ये ही चाहिए था, ए है ना. अब सही है, सॉरी माय बैड. इसको चेक कर लेना, मेक श्योर यू डू करेक्ट दैट, है ना. तो दिस हैज टू बी एम. आई वांट टू फाइंड द वी. कोई दिक्कत नहीं है, एम को इस तरफ ले आओ और सब रूट हो जाएगा, तो आपको जो वेलोसिटी हो जाएगा दैट इज गोना बी एफ माइनस म्यू एम जी, और टी हो गया और अपन को नीचे एम मिल जाएगा. So this is the velocity at any time t. This is the answer for the next part of the question. All good बच्चों, ठीक है ना जी? Oh, any issues with this so far? बहुत अच्छा. चलो एक और क्वेश्चन करते हैं. अच्छे क्वेश्चंस बहुत हैं इस टॉपिक को करने के लिए. यू कैन गेट मल्टीपल क्वेश्चंस ऑन दिस टॉपिक. बहुत सारे आपको क्वेश्चंस मिल जाते हैं. कॉन्सेप्ट को धीरे धीरे समझते जाओ मजे में, और हम लोग ऐसे ही आगे बढ़ते रहेंगे. ठीक है जी? Good. And also do practice, do practice a lot. जितना ज़्यादा you guys do practice, better will become. So, besides, apart from these numericals which I'm doing with you, you must give a lot of input from your side. You must do a lot of practice. जितना ज़्यादा practice करोगे, my dear guys, you will be getting better with that. ठीक है. So we are done with this question. Let us move towards next question, where I'm going to show you certain graph. कुछ ग्राफ का डिस्कशन हम लोग करते हैं. ओके, लेट्स सी वी हैव अ ग्राफ वेयर आई एम सेइंग दैट एन ऑब्जेक्ट इज मूविंग इनिशियली विद अ वेलोसिटी ऑफ 4 मीटर पर सेकेंड, एंड आई एम गिविंग यू द ग्राफ ऑफ एफ वर्सेस एक्स. एफ वर्सेस एक्स का ग्राफ दे रखा है, मींस फाइंडिंग द वर्क वुड बी इजी फॉर यू, राइट. वर्क इज एफ डॉट एस, अपने को ही पता है, दैट्स व्हाट वी नो ऑलरेडी. नाउ इफ आई गिव यू द ग्राफ ऑफ एफ वर्सेस एक्स, and let us say that initially at time t is equals to 0, or whatever time I'm choosing, when I'm starting the motion, the velocity of the object is 4 meter per second, and the mass of the object is, let us say, 2 kg. And the graph is like this, starting at 4, crossing this at 1, going to -4. So this is your -4. Okay, इसको ध्यान देना, ठीक है. Now this is 1, let's say this is 2, 3, 4, थोड़ा इसको बड़ा कर लो, एक्सटेंड कर लो, है ना, 2, 3, 4, 5 तक रखते हैं ना, 2, 3, 4, and let's say this is 5, and after here the body is moving like this, you know, this is your -4, this is all what we have. Now going further, what you need to understand is कि initially the body was moving at 4 meter per second, mass 2 kg दे रखा है, and the force is over here is 4, and here we have -4. Now the question to you, my dear guys, is number 1, find कितना ही करने होगा, kinetic energy, find kinetic energy at x is equals to 3, and the second question could be I'm asking you to find the kinetic energy at 3. You know, I could also ask you at what distance or displacement, जो भी रखो, what distance kinetic energy is going to be 8 joule. वो कितना डिस्प्लेसमेंट चाहिए होगा कि उसका kinetic energy 8 जूल हो जाए, दैट इज द सेकंड पार्ट ऑफ द क्वेश्चन बच्चे, है ना, वो हमारा सेकंड पार्ट है. वीडियो पॉज करो, गिव इट अ ट्राई, एंड देन वी गोना गो फर्दर टुगेदर. ठीक है, आई बिलीव यू हैव गिवन अ ट्राई टू दिस, ऑनेस्ट ट्राई, एक जेन्युइन ट्राई आपने दिया होगा. ठीक है, नाउ लेट्स मूव टुवर्ड्स द सॉल्यूशन. We know that the energy is the work done is what? Work done is given as F dot ds. अपने को ये पता है. Now, if I want to find, let's suppose कि total work done, then I have to integrate this. Integration of a curve is all about the area under that curve between the variables what we have. तो इसका इंटीग्रेशन बच्चों क्या हो जाएगा? एरिया ऑफ these part of the curve जहां पे हमारा f और x का वैल्यू दे रखा है, because f dot ds is the work done. Now what we need to understand is 3 पे कितना होगा जी. So at 3 we're going to find the area between the fx curve at the time till time t is equals to 3. So this is nothing but area under the curve. This integration is all about area under curve. Now we need to ensure that जो भी आप एरिया लिखो, इसका एरिया आप पॉजिटिव लोगे, एंड इसका एरिया और जितने भी नेगेटिव से उसका आप नेगेटिव लोगे. एरिया अंडर द कर्व विथ साइन, वेरी इंपॉर्टेंट, कुछ बच्चे साइन के साथ ऐड नहीं करते हैं एंड देन दे गो रॉन्ग. वी नीड टू ऐड द एरियाज अलोंग विद द साइन. Okay, going forward, if I talk about the area of this part, it is how much? Half into base is 1, height is 4. So I'm going to have half into base into height, which is 4. अपने को एरिया मिल गया इस पार्ट के लिए. Area of this part should be negative. Base is 1, height is -4. So we'll have minus half into base is 1, height is 4. Now area of this part should be how much? Area of that part should be your 4 into 1 with a minus sign. So we'll be having minus of 4 into 1. Now this is the total work done, and we know that the net work done on a particle system is equals to the change in the kinetic energy. अपने को वो पता है. So let us figure out the work done. That should be how much? 2. This is also going to be 2. That is going to be -4. Well, that is going to be -4 joule. So what are they asking? They're asking you the kinetic energy at x equals to 3. So from the work energy theorem, we know that work done is equals to change in kinetic energy. Initially, what was the kinetic energy? Since the velocity of the body initially is how much? 4 meter per second. So the initial kinetic energy is half mv square. We can use that. And final, we need to find, final अपने को चाहिए होगा. तो kinetic energy final minus initially is how much? Half into m into v square. That means how much is work done? -4 is equals to final kinetic energy minus 16. So the kinetic energy बच्चों is going to be 12 joule. So that is your answer, and yes, it is done. ये हमारा हो गया है ना? All good? चलो. Now let us move towards the next part where they're asking you at what distance the kinetic energy is equals to 8 joule. Okay, in this part it is definitely not going to be the same. It's how much? 2 दे रखा है, तो अपने को वो तो नहीं है ना? Correct energy. Initially the kinetic energy how much? Half mv square. तो half into आपका जो भी mass 2 है और velocity दे रखा है 4, तो half mv square हो गया. तो मान लो कि कहीं भी x distance पे x distance over here, वो distance x dash ऐसा मान लो कुछ इधर है. At this point the kinetic energy comes out to be 8 joule. बिकॉज 12 जूल कहां पे है, 3 पे है ना, तो 8 जूल किधर होगा, दैट इज व्हाट वी हैव टू फाइंड, अपने को वही तो निकालना है। तो एक बार ट्राई करो, एक बार ट्राई करो और फिर हम लोग आगे बढ़ेंगे, है ना। चलो कोई दिक्कत नहीं, आई एम श्योर यू गाइस मस्ट हैव गिवन अ ट्राई, लेट अस डू इट टुगेदर। पार्ट 2। Okay, initially, what is the kinetic energy? Velocity is 4, तो हाफ एम वी स्क्वायर कर देंगे, इनिशियली उसके पास ना kinetic energy है। दिस पार्ट का वर्क डन ऑलरेडी वी हैव फाउंड, तो उसको बार बार करने का जरूरत नहीं है। तो अगेन वी गोना यूज दैट, सो वर्क डन बाय द नेट फोर्स इज इक्वल्स टू चेंज इन द kinetic energy, अपने को पता होना चाहिए। तो वर्क डन कितना हो गया जी, फॉर फर्स्ट पार्ट इट इज 2, सेकेंड पार्ट इट इज -2, और उसके बाद मान लो कुछ भी डिस्टेंस x डैश पे है, तो ये डिस्टेंस, दिस डिस्टेंस इज गोइंग टू बी हाउ मच, x डैश -2, आई एम टॉकिंग अबाउट दिस लेंथ, इफ आई टॉक अबाउट दिस लेंथ इज गोइंग टू बी हाउ मच, total is x -2, so that length is going to be, that length, and it's going to be negative क्योंकि वो नीचे है, तो minus of force is how much, 4, and that length should be how much, x dash -2, right? So this is the net work done, this is the net work done, and we know that at this point at this point the kinetic energy is how much, 8 joule, that's what they are saying. So let us suppose this is the change in the kinetic energy, this is the change in the kinetic energy as per this rule. भैया ये तो गया आपका, है ना, let me use a different color, ये थोड़ा मिक्सिंग हो जाएगा, है ना। ध्यान दो, तो नेट वर्क डन कितना हो गया बच्चों, आपका हो गया -4 times of x dash -2, and that is should be equals to the change in kinetic energy। और अपने को पता है कि इस पॉइंट पे कितना है, at what distance kinetic energy is equals to 8 joule, अपने को पता है कि यहाँ पे 8 जूल होना चाहिए ना, ठीक है। तो फाइनल kinetic energy is 8। initially how much it was, initially velocity is given as 4 meter, तो हाफ एम वी स्क्वायर कर दो, तो -12 into m into v square which is 16, करेक्ट है ना, वेलोसिटी वाज 4, चलो बढ़िया। तो दिस इज गोइंग टू बी हाउ मच, तो ये कुछ कैंसिल कर दो ना, तो कितना हो गया, 8 - 16 -8 हो गया, और वो कट जाएगा, तो आपको हो जाएगा x dash -2 -8 4 2, it means x dash is going to be 4, means at 4 the kinetic energy is going to be 8 joule। बेसिक क्वेश्चन था, इजी था, विद द ग्राफ, क्लियर है ना। इफ नॉट डू वॉच इट अगेन, एक बार देख लो, रिवाइज कर लो, बड़ा अच्छा क्वेश्चन है, काम आएगा, ठीक है जी। राइट देन लेट्स मूव टू द नेक्स्ट क्वेश्चन। उसके पहले मैं थोड़ा इसको इरेज कर लेता हूं जी, लेट मी इरेज दिस। आई बिलीव यू गाइस हैव नोटेड इट डाउन, नहीं तो कोई नहीं, यू कैन पॉज द वीडियो एंड इजीली नोट इट डाउन। So that's a advantage of recorded video lessons. You can actually pause it, play it on your will, but ensure that you do not pause it for the longer time. रोक के आप लोग घूमने फिरने न चले जाओ। A lot of kids do that. They do pause it and go for playing and then come back, and by that time they should be into the next lesson, but अभी भी वो इधर ही अटके होते हैं। Anyways, let's move on towards one more good question. So today I'm doing quick few good question, और आप इसको करना छोड़ना नहीं है ना। चलो, there is one more question that we can try. Let's say a bullet is fired and it enters a block, a wooden block में, let's suppose thickness is T1, it enters the wooden block and it loses अपना ये जो एनर्जी इसके पास है, इनिशियली ये लूज करता है कितना, 4/5 एनर्जी, 4/5 ऑफ एनर्जी इज लॉस्ट, सॉरी 1/5 कर दो, 1/5 ऑफ द एनर्जी इज लॉस्ट। वो जैसे ही उसमें एंटर करता है वो अपना 1/5 ऑफ द एनर्जी लूज कर देता है, करेक्ट है ना जी। 1/5 of the velocity कर दो ना, 1/5 of the velocity, 1/5 of the velocity is lost, and after that it enters one more plank, one more block, and इसका thickness is, let's suppose T2 है, and this bullet managed to just come out of it, जस्ट इसके बाहर वो आ जाता है, इट जस्ट मैनेज टू कम आउट ऑफ दिस, वो इसके बाहर आने का जस्ट मैनेज कर लेता है, एंड देन इट स्टॉप्स। गेटिंग माय पॉइंट? सो अ बुलेट इज पासिंग, एक बुलेट है वो पास कर रहा है थ्रू टू ब्लॉक्स, एंड इन द फर्स्ट केस इट लूजेस 1/5 ऑफ इट्स वेलोसिटी एंड इट मैनेज टू पास फ्रॉम द सेकंड, है ना। और दोनों का जो रेजिस्टिविटी है, दोनों का जो रेजिस्टेंस है इज सेम, यू नो, both the blocks have the same material, ऐसा मान लो, same material, you know, and they have the resistance to the average penetration same ही है. You have to find me the ratio of the thicknesses of the block 1 and the block 2. Find the ratio of T1 and T2. Find the ratio of T1 and T2 is your question. Now pause the video and give it a try, and then we're going to do it together. Simple सा question है, एक बुलेट आया, it crossed the block 1 and it lost certain amount of velocity, जो कि कितना दे रखा है, 1/5 of the velocity वो lose करता है, and then subsequent next box when it passes it actually comes to a rest, but it just manages to cross that, है ना, वो रुक जाता है, it means it has lost the remaining velocity while crossing the second block को, you know. You have to find me the ratios of the thicknesses of the block 1 and the block 2. चलो इसको ट्राई कर लो. ओके, आई बिलीव यू गाइज मस्ट हैव गिवन इट अ ट्राई, आपने इसको ट्राई कर लिया होगा. अब साथ में करते हैं. देखो कोई बड़ा बात नहीं है, आपको समझना चाहिए कि इस ब्लॉक ने कुछ काम किया है टू स्टॉप द बुलेट. Likewise, even this block has done certain amount of work to stop the bullet, or maybe resistance इसको दिया है. Now initially let us suppose कि इसके पास velocity v है. Let's say the velocity is v, and when it crossed and when it entered this block, उसका velocity कितना हो जाएगा जी? At this point the velocity should be 4/5, है ना? Because it has lost 1/5 of the velocity, so here velocity should be 4/5 of v, and when it comes out the velocity is 0. So there is a loss of energy, right? And we know that work done is equals to change in the kinetic energy, and work done is all about the force into the displacement, and since both are of the same material, so they would offer the same amount of force of resistance to the bullet, you know. So can I say that over here work done in this case is, let's suppose 1, here the work done is 1 and here the work done is 2. So work done 1 upon work done 2 should be given as how much? Change in the kinetic energy over here, delta change of kinetic energy 1 and delta that is change of kinetic energy 2 in this case. इस relation पे we gonna go forward और हमारा काम easily हो जाएगा, right? In this case, let us suppose the resistance force which it is going to offer is F, and distance that bullet has to go through to cross this has to be T1, and in this case it is going to be T2. Now what is the change in kinetic energy, bachcho? Final kinetic energy is how much? Because the velocity which is coming is half m, v is how much? 4/5 v whole square, and initial kinetic energy was how much? Half m v square upon, when it comes to this case, the final kinetic energy is 0 and the initial kinetic energy was how much? Half m 4/5 v whole square, because it entered this block at this velocity. This force is going to get, you know, cancelled out, and we should be having T1 upon T2, and that should be, my dear kids, half mv could be eliminated quite easily. Half mv could be easily eliminated, है ना? Half mv could be easily eliminated. So what I'm going to be left over here, we're going to have 16 upon 25 v square minus let's say v square. You can take half m over here, and down we should be having how much? Negative 1/2 m 16 upon 25 v square. This should be cancelled, even v square should be cancelled, and we should be having negative 9 upon 25, and here we should be having how much? Negative 16 upon 25. So the answer has to be 9 upon 16. So thickness of these two should be 9 upon 16. All good, kids? All right then. Let us move quickly to the next problem. I believe आपने इसको नोट डाउन कर लिया होगा. चलो फटाफट एक और क्वेश्चन करते हैं. Let us do question number 4. तो Before we do this question, I would like to tell you that there is a, let's suppose a block is kept over here. Let's say a block is kept over here, and there is a pulley. Now another block is hanging over here. Another block is hanging over here. Now let's suppose there is a friction between these two planks. इसके बीच में friction है और इसका mass मान लो m1 है and इसका mass is let's suppose m2 and there is a friction between these two block and this plank है ना. इसके बीच में एक friction है surface and block. ठीक है. They started from the rest. They started from the rest. Let us say. Now there's gonna be a time when the object would start moving, the blocks would start moving at a constant velocity. They start moving at the constant velocity. आपको उस velocity का value निकालना है. आपको उस velocity का value निकालना है. And let us say that they start moving after traveling distance L. They start to move at constant velocity. चलो इसको proof टाइप में कर लेते हैं ना. Prove that velocity, the constant velocity is given as 2 times of, इसको हम देख लेते हैं, 2 times of m2 minus m1 upon m1 plus m2 lg है ना. 2 times of, ऐसा है ना, 2 times of lg. ठीक है. you have to prove that. अच्छा, म्यू को भी इंट्रोड्यूस करते हैं. यहाँ पे म्यू होगा, मिसिंग है, म्यू टाइम्स ऑफ m1. So let's say after traveling a distance of L, they start to move at a constant velocity, a constant speed. आपको प्रूफ करना है कि भैया that constant speed is going to be equal to this. Question clear है? चलो ट्राई करो. ठीक है. तो इसको आपने ट्राई कर लिया होगा. इसको मैं इरेज करता हूं. Let me erase this part and then we're gonna do this one. Good. I believe you guys are understanding what I'm teaching and following it properly. All good? ठीक है. Now let us see that initially what's going to happen. This block, if I look at this block M2 should be having a pull, downward gravitational pull and a tension upward. All good? Now that tension is going to drive the block 1. ये tension ही इस block 1 को drive करेगा. Now block M1, if I look at this, so they're going to be a tension T and a tension T over here. Now this block should be facing a frictional force in this direction because the block has a tendency to move towards right. All good? Now the blocks would move with a constant acceleration because the net force is constant. Gravity is going to be constant, and if the block starts sliding, the friction force also is going to be constant. That is a kinetic friction. Now let us say that the block is having an acceleration of A. So this block also should go down with a acceleration A. So both the blocks would have a common acceleration. निकालने का तरीका बहुत है. आप चाहो तो m2g minus t 1 equation and t minus friction force should be m1 a is 1 equation. What I'm going to do is if I look at these two blocks as one system, the net driving force and the net opposing force, if I take the difference of that and divide by the mass, I should be getting the acceleration quite easily. तो इसका acceleration निकालना कोई मुश्किल काम है नहीं बच्चों. तो common acceleration should be m2g is a driving force minus the friction force. So iska FVD, if I draw, you can see there's going to be a tension in this side and there's going to be m1g. There should be a normal reaction and there should be a frictional force in the leftward direction. Now friction force should be how much? Mu times of normal, that is mu times of m1g. That is going to be the opposing force, the friction force over here. Upon the total mass, that is m1 plus m2 is going to be your common acceleration. ये अपने को एक common acceleration अब मिल गया. All good? Now since we know that we have the common acceleration this much, I can assume that let's suppose the common velocity or the constant speed at which they are moving is let's suppose v. हमने एक speed मान लिया v. Now that speed should be attained or achieved by these two blocks in the same time क्योंकि दोनों connected है. तो लेट अस सपोज कि टाइम टी पे वो अचीव कर गया. Anyways, initially they had zero velocity. Initially, when we left the system, they had no velocity. All good? अब देखो इसमें क्या कर सकते हैं. इसका velocity in some time t should be same. Or after traveling a distance of L, they have mentioned. So can we use v square minus u square is equals to 2as? कर सकते हैं ना? I think that should be the better way to go for it. So v square minus u square is equals to 2al because s over here is L. दोनों ने L distance को travel करा. Now, so v square is going to be 2 times of al. A is how much? We have found it already. That is your m2g, or you can take g common. You can take g common. m2 minus mu times of m1 g. That is your acceleration upon m1 plus m2. All good? Now, what is the distance? That is L. So let it be here. So the velocity, the common velocity should be how much, kids? That is going to be m2 minus mu times of m1 gl upon m1 plus m2 over the root. That is proved, isn't it? So do not get scared, do not get intimidated by the appearance of the question. You must stick with your concepts and the fundamentals, और question बनेगा ही बनेगा. ऐसा नहीं कि वो नहीं बनेगा. चलो, having done this, let us move towards next question. And before that, I must erase this. तो फटाफट इसको erase कर लेते हैं. So guys, I'm targeting, I'm trying to upload the videos in such a way that after each concepts, I must deliver to you 5 to 10 numericals. Because, in physics, especially in these particular topics, your concepts would be evolved, would be, I would say, sharpened if you do more practice. और मैं बार बार बोलता हूँ कि आप practice करो. That's the reason why I try and give you some confidence by solving, as many problems as I can do. But again, these restrictions on the video side, we cannot do upload a lot of videos, a lot of questions. Time बहुत ज़्यादा लग जाता है. For that, you can reach out to me और हम लोग साथ में कुछ practice कर सकते हैं. चलो एक और question करते हैं. Let us do one more question. Number 5. Now let us suppose we have a plank. एक plank है and a block is kept on this plank. A block is, where is the red marker? It is here. Okay, let us place a block on this plank. It is at this end, ऐसा हमने रखा. Let's suppose the mass of this block is small m and mass of this plank is m. It had a velocity, initial velocity of, let's say, v naught. It had an initial velocity of v naught, and this surface on which the plank is kept is smooth. There is no friction. So friction over here is 0, and on this surface we have certain friction. We have certain friction. All good? Length of the plank, let us say it is L. Is L. Just for your info, length of the plank I'm giving you as L. Now the question tells you that, let me read the question. A plank of mass m is there, kept on the smooth surface, and a small block m is kept on the plank. And the mass is projected with velocity of v naught, right, from the left of it, having the friction coefficient as mu between the block and the plank. And its value is such that the block becomes stationary with respect to the plank, when it reaches the other end. मतलब यहाँ पहुँचते पहुँचते वो रुक जाता है. It does not jump out of the plank. वो इसके respect में, with respect to this, it comes to rest by the time it reaches the other end of the plank. Now the question to you is, find the time and the common velocity. The question is find the time and common velocity when velocity of the block with respect to plank becomes 0. Means ये जो block है plank के respect में move करना stop हो जाए, उस time पे आपको निकालना time कितना लगेगा और उस point पे velocity कितना है. Question बहुत simple है. This was given a initial velocity of v naught and it is staying on a plank, and the surface has friction with a coefficient of friction as mu, whereas the ground and the plank has no friction, that's a smooth surface, so the coefficient of friction is going to be 0. Now since it has a velocity, so definitely it is going to drag this plank as well with it, and after some time, because of the friction, its velocity hoga decrease, and we're going to reach a point when the velocity of this block and the plank becomes equal from the ground frame, इसका मतलब कि अगर कोई इंसान इस पे ऑब्जर्व कर रहा है, then in that case the velocity of the small mass m with respect to the bigger plank is going to be zero. All good? That is going to be zero. That is going to be zero. आपको टाइम निकालना है और वो कॉमन वेलोसिटी निकालना है जब उसका वेलोसिटी जीरो हो जाए. वीडियो पॉज करो और इसको एक ट्राई दो. आई एम श्योर यू गाइज वुड बी एबल टू डू इट, है ना. चलो ठीक है. सो आई बिलीव यू गाइज मस्ट हैव गिवन इट अ वेरी जेन्युइन एंड ऑनेस्ट ट्राई. आपने इसको अच्छा ट्राई दिया होगा. अब हम इसको साथ में करते हैं. लेट अस डू इट टुगेदर. Okay, देखो सिंपल सी बात है. If I look at this block, there going to be a friction. There going to be a friction because if you observe it from this frame slowly, okay. Let's suppose a plank है बच्चों. This is the plank, and if I'm observing it, this small block from this plank, देखो क्या होता है. It has a velocity of v naught, है ना. So with respect to this plank, it has a tendency to move rightward. It means कि इस पे एक friction आएगा. On this block, there going to be a friction in the left side. ये इसको रोकने का कोशिश करेगा. Now, and this block would also exert the equal and opposite friction on this plank, and this friction would be responsible for the movement of the plank. इस plank को इसी frictional force के कारण आगे जाना होगा. Now, if you look at this one, initially it would be having some velocity, but because of this frictional force, there should be some acceleration in this direction. और धीरे धीरे slowly it is going to retard, deaccelerate, और इसके velocity के बराबर हो जाएगा. Now, this block would be having some velocity also because of this friction force, but that is not going to increase. वो force रहेगा हमेशा, तो इसका velocity क्या होगा? बढ़ेगा. The velocity would increase, but the force of friction will remain constant. The velocity would increase. And there going to be time when इसका velocity और इसका velocity equal हो जाएगा. ये हमारा हो गया approach to this question. अब हम इसको solve करते हैं. Now let us going to we gonna solve it out, है ना. तो first of all let us find the acceleration. Let us find the acceleration. देखो acceleration क्या हो जाएगा. If I look at the plank, acceleration of the bigger mass m should be force of friction upon the capital mass. Force of friction mu times of normal. इसका नॉर्मल निकाल लो, कोई दिक्कत नहीं है. दैट इज गोना बी mg. उसका लिखने का जरूरत है क्या. तो एक्सेलरेशन ऑफ द ब्लॉक शुड बी हाउ मच, म्यू टाइम्स ऑफ mg अपॉन योर m. तो दिस इज गोइंग टू गेट कैंसिल्ड और ये आपको पता है, आप हमेशा इसको यूज कर सकते हो. सो द एक्सेलरेशन ऑफ दिस इज गोइंग टू बी म्यू g. एक्सेलरेशन ऑफ दिस यू कैन नाउ राइट इट डाउन बिकॉज आई नो द फ्रिक्शन फोर्स. सो म्यू टाइम्स ऑफ mg अपॉन कैपिटल M. सो आई हैव टू थिंग्स. राइट, ऑल गुड. ठीक है जी. Now let us take the time in which the velocity becomes equal, है ना. Velocity becomes equal. तो in time t the velocity becomes equal. Velocity becomes equal. Velocity becomes equal. So v should be how much? U plus at we can apply. Initially it has a velocity of u naught. So this is gonna be v naught. A is how much? Mu times of g into t. अपने को मिल गया. Let us talk about this one. The plank. This is the third equation. You can assume. Plank का क्या हो जाएगा? If I look at the plank, initially it was at rest, so the final velocity could be written as 0 plus at. A is how much? Mu times of mg upon capital M into t. Now both these velocities are same, they are equal, so I can easily equate these two and I can get the value of time. तो चलो इन दोनों को equate कर देते हैं. तो we should have what? We should have v naught minus mu gt is equals to mu times of mg upon capital M times of t. इसको solve कर लो easily, है ना. It's not a big deal. आप इसको उस तरफ लेके चले जाओ. तो v naught is equals to mu gt plus mu mg upon capital M into t. We need to find the value of time. So v naught is equals to, let us take the value of t here common. So we'll have mu g plus mu m, है ना, g upon capital M, and then you can easily simplify करके आप इसको लिख सकते हो. तो you can also take the mu g common. तो t into mu g you will be having, इसको बाहर ले लोगे तो क्या हो जाएगा बच्चों? You can take mu g common, आपको हो जाएगा capital M plus small m over the capital M. इसको थोड़ा सा कैपिटल दिखा देते हैं और ये आपको हो गया. All good. So the finally what we get is, so t should be given as m v naught upon capital M plus small m into mu g. So this is the time in which they would attain a common velocity of v. और common velocity v निकालने के लिए क्या करेंगे अभी? I'm going to replace the t with this value. अपने को common velocity easily मिल जाएगा. तो चलो मैं इधर कर देता हूँ, ठीक है? I'm going to do it here. So that common velocity should be mu mg upon the capital M. टाइम की वैल्यू कितना है? कैपिटल M v नॉट अपॉन कैपिटल M प्लस स्मॉल m टाइम्स ऑफ म्यू जी. कुछ कैंसिलेशन हो रहे हैं क्या? यस, वी कैन सी m would get cancelled, mu g should be cancelled. So the common velocity, my dear kids, is going to be mv naught upon capital M plus small m. Capital M plus small m. So that is your common velocity. That is your common velocity अपने को मिल गया. और सही है ना? हाँ, बहुत सही. और आपका टाइम भी मिल गया है जब वो वेलोसिटी आपका आ जाएगा. ठीक है. सो लेट अस रैप अप दिस सेक्शन हियर इटसेल्फ. हम लोग नेक्स्ट सेशन में और भी कुछ अच्छे प्रैक्टिस क्वेश्चन करके आई एम गोना मूव टुवर्ड्स क्विकली टुवर्ड्स द पोटेंशियल एनर्जी. और बहुत अच्छा कॉन्सेप्ट है and I'm going to try to make you guys understand to its fullest. ठीक है. So till then, keep studying and keep learning. And yes, thanks for watching. I'm going to see you in the next video. Take care. Bye everyone.